Hello everybody, and welcome back to the Poor Man's Chemist. In this video, we are going to be making thorium sulfate, pure thorium sulfate this time, from thorium hydroxide, which I have here. You can see it is a mostly white powder. That's what pure thorium hydroxide is supposed to look like. There are some little bits in there that are a darker color. And I think that's just because a little bit of sulfate impurity made their way into the final product. This is not a big deal since we are going to be making sulfate anyway, and I would imagine that we're going to have to use slightly more than a stoichiometric mix of sulfuric acid. We're going to try to keep it as close to stoichiometric as possible, though, so that we can evaporate down the solution and obtain some, hopefully, nice, beautiful crystals of a thorium sulfate hydrate. What I have here is some ammonium diuranate. I would reprocess my uranium recycling again, and I dried it out, and I'm not sure exactly how much is here. It's a few grams. And I thought I would show you guys a comparison between the two elements. So here we have 5.25 grams of thorium hydroxide. I hope that this piece of shit is focused and you can see that. Can you see that? Come here. There we go, that's better. You can see it's like, even this close to it, it is still pretty damn tame. I actually, before filming, I let this sit over this for a while, and it will finally trip the alarm, which is triggers at 100 counts per minute. But it took a little while to do it, for it to trip it and it to stay on. I'm holding it a little bit closer now than it was then, trying to get as good a reading as possible without dropping it into the thorium hydroxide. Anyway, so you see it sits 100-ish, something like that. I think we're at 130 something now. And let's compare that with uranium. We're not even, like, well, we're still, what is that, an inch, maybe two, above the uranium. And this is depleted uranium, mind you. This is not enriched uranium. As much as I wish I had enriched uranium. I mean, uranium-235 has a half-life of like 700 million years. It's not exactly screamingly radioactive, especially compared to other things like plutonium. So I just thought it would be cool to illustrate just the difference in radioactivity there between thorium and uranium. Those damn nuclei start falling apart once you get up towards 92. Or is uranium 90? Damn, I'm a bad chemist. I can't remember what element number it is. Anyway, on with the show. Okay, so we've got our thorium hydroxide in here, and I've added a little bit of water just from rinsing all the thorium hydroxide dust out of the evaporating dish into there. Now, I am going to add, well, the stoichiometric calculation was 11 and change, but I'm just going to go with about 12 mils of 1.55 molar sulfuric acid, because that's what I've got already made up. Volumetric pipette. Alright. Now the little particles seem to go into solution pretty quickly, so maybe this will be relatively painless. That would be nice. Okay. Come on, volumetric pipette. There we go. Alright, that is 12 milliliters. Turn on the heat, cap it, And now, you know what? It is, thorium sulfate is not terribly soluble at low temps. I think Wikipedia said like 3 grams of thorium sulfate will go into solution in 100 mils of water at 20 C, I think. So add some more water there. Make sure we don't have any solubility issues. Turn on the heat. I will put a foil cover around the beaker, and I will come back when there is a change to report. Okay, everyone. So I checked on this thing, and it was not dissolving. And I added a few drops of concentrated sulfuric acid to it, which seemed to help. And then, after a little while, I went and I checked on it, and this had happened. Now, thorium sulfate is not supposed to be that soluble, and it may be like the lanthanides, where the solubility is inversely proportional to the temperature. It certainly didn't look that way from where I was looking at it on Wikipedia, but that could explain why it kind of stopped at about 20-ish C or so. So what I'm going to do is I'm going to add some more water to this in here. It's transferred to a larger beaker, and I'm going to turn off the heat, and I'm going to let it keep stirring, and I am going to see if we can't get everything to go into solution. I think I need some more water. I mean, I would be willing to accept that it's thorium sulfate if the final pH is good and acidic. I mean, it could just be the common ion effect doing its thing. I mean, all of the chunks that we seem to have do indeed appear to be gone, but I want to make sure that they're gone. Well, here is the pH of the solution. It's like 2. So it is definitely very acidic. It's cooled down a good bit. It doesn't look like a whole lot has changed. Whoa. Okay. Okay, so I poured off everything but the large chunks. All of the stuff that was easily suspended in the liquid, I poured off into here. I'm pretty sure this is thorium sulfate, I think. I don't know. A little bit more water to this, and try breaking up some of these large chunks here, so that if it is passivated hydroxide, hopefully we can break through the surface coating. Oh, well, I don't know. Okay, everybody, it is the next day, and my suspicion is confirmed. Thorium sulfate is, its solubility in water is inversely proportional to temperature. You can see, it ended up being in 2 beakers. I'm evaporating it down. But I'm about to filter it because there was a little bit of jizz at the bottom of one of the beakers. I'm not really sure what that was. I don't want it showing up in my final product. But yeah, so what I'm going to do is I am going to, like I said, I'm going to filter everything. And then I am going to combine these solutions. I am going to heat it up and evaporate it down till it's about 100 mils or so in volume. That should get the vast majority of the thorium sulfate to crash out of solution. I will filter it off and then evaporate down the rest of the filtrate to get the rest of the thorium sulfate. That seems to be the best way to go about it. I just thought it was very interesting. You know, here we have an excellent example of a compound who has its solubility is inversely proportional to temperature. A lot of the lanthanide sulfates are like this. In fact, I think all of them may be. I'm not sure. Don't quote me on that. But if not all of them, then the vast majority of them have a solubility that's like this. So it's a cool little quirk of chemistry, huh? Okay, so this is the final evaporation that I'm doing to obtain the purified product. And you can see it's really cold out here, and this is evaporating down kind of slowly, even though I have it inside and it's all wrapped up as much as possible. But I think because of just how slowly this is evaporating, I'm starting to get some pretty big particle sizes of these this thorium sulfate. It's pretty cool. I hope that's showing up well. Okay, everybody, so here is our final product. You can see it is just a white solid. As it precipitated, I guess, yeah, as it precipitated out of solution, you get these pretty decently sized particles. They tend to be kind of big, and they tend to clump together, and that makes them very, very easy to filter. This is some of the easiest stuff to filter I have ever seen. But when you're evaporating it down, the solution bumps worse than anything I have ever seen in my life. I've never seen bumping like that. I'm surprised it didn't knock the beaker right off the hot plate. So it had to be stirred with, as you evaporated it down. If you don't stir it, it is going to bump until it blasts itself out of the beaker, which almost happened twice. Like I said, I've never seen anything that did that like this. And you can see here, we are definitely getting a reading off of this stuff, so that confirms that the thorium is indeed... Whoa, come on. So we definitely have thorium in this stuff. It is exactly what it's supposed to be, and I feel pretty confident saying that, you know, this is it. This is pure thorium sulfate. So if you like that video, give it a thumbs up, and if you didn't, well then oh well. Subscribe, comment, share the video far and wide, and until the next one, y'all, I will see you later. That is pretty goddamn cool, man. It really is. That is a cool fucking compound.